The water does not just rise from the oceans anymore, it rises because the Earth itself is giving way, and Texas is home to the fastest sinking city in America. For years, the global conversation around climate change focused on melting glaciers and warming oceans, pushing sea levels upwards. But in coastal hubs across the planet, scientists are confronting a much more immediate subterranean reality. The land beneath the feet of millions of urban residents is actively sinking, collapsing under the pressure of human development. It is an environmental phenomenon known as land subsidence. So while the global ocean climbs, albeit slowly, the coast is actually pushing down to meet it. A global study published in Nature Communications revealed that people living in heavily populated coastal regions experience an average relative sea level rise of about 6 millimeters per year, nearly 3 times the global average of 2.1. The mechanics of this collapse are largely driven by a resource fundamental to urban growth: water. As cities expand, they pump massive amounts of fresh water from underground aquifers. When these underground reservoirs are drained, the deep layers of clay and sand compress under the weight of the city, causing the earth to deflate. Now, there are several major international cities that stand out as extreme subsidence hotspots. Jakarta, Indonesia is sinking at an average rate of 13.7 millimeters per year, with some localized areas plunging by up to 42 millimeters per year. In fact, the crisis is so acute that the Indonesian government is actively building a new capital city further inland. Tianjin, China is a massive port city, and it's dropping by 13.5 millimeters per year, with Bangkok, Thailand plunging at about 8.5. Now, this is not a crisis isolated to developing nations or distant deltas. In the United States, the nation's most populous urban areas found that subsidence is a widespread domestic threat. Among all major U.S. cities, Houston, Texas is the fastest sinking, with more than 40% of its area subsiding faster than 5 millimeters per year. Decades of intense groundwater extraction and oil and gas pumping have left the region highly susceptible, and when the land drops, gravity stops working in the city's favor. Rainwater from severe storms cannot drain efficiently into the Gulf, trapping floodwaters inland, exacerbating natural disasters. Over time, subsidence can crack water lines, fracture foundations, and even compromise transit systems. Now, some cities have shown that the problem can be slowed. Tokyo, which sank by several meters during the 20th century, largely stabilized after banning groundwater extraction and requiring industries to use surface water or recycled alternatives. Ultimately, the sinking of global cities demands a shift in how we think about climate adaptation. For decades, planners have looked to the horizon for rising water, but they are now realizing the more immediate danger may be the ground giving way beneath our feet.